I guess I would say these are things to know / review for your final exam. As I said, I could say topics, maybe is a better word. Things, topics. All right, so let's just start from the very beginning. Differential equations. I would imagine you'll probably be asked to solve a differential equation of some sort, maybe even two of them. There are two types. It's either going to be separable, meaning you write it as dy dx equals something with just x's times something with just y's. And then if you get it to this, right, if you have dy dx equal things with just x's and y's, then the way we separate this is we say, okay, 1 over g of y, whatever g of y happens to be as a function of y, times dy equals f of x times dx. And then you integrate both sides. But the idea, right, is to get dy dx equal to things with x's, things with y's, and then bring all the y's to the left, all the x's to the right. Or it's going to be first order linear differential equation. And that's where at some stage, you have to be able to write the equation as y prime plus some function of either x or t usually times y equal to some other function of x or t. It has to be plus. So if it's not, so here, but that's actually an excellent question. So let's pretend for a second, let's say our equation was given as, like y prime minus x squared times y equal to, I'm going to say x. Well, then my p of x would be negative x squared, because this is y prime plus negative x squared times y. That's the way to think about it. And then the solution would be, the solution is going to be, in general, y as a function of x equal to 1 over your integrating factor times the integral of q times your integrating factor. That is mu. That is usually what we call it. Yeah, mu of x is the integrating factor. Zoom in a little bit so you can see it better. And I suppose along with differential equations, it's possible, although I would be willing to say probably not very likely. You could also maybe have a tank problem. I don't know, it's potential. All right, so that's where you have to set it up, right? So you have to say that the rate of change of whatever, like salt or sugar or whatever is like mixed into your thing, is equal to the rate in minus the rate out. I don't know. That's a question you could ask your teacher. I doubt he will give you any better answer than well. The second thing, or the second kind of general area, so that's like the section appendix C stuff, whatever. Then we have the chapter 7 stuff. So like 3D stuff. Well, yes and no. So like, yeah, he's not going to ask you to identify like the surfaces we were talking about, but he could still ask you to like draw a point in space. But also there's then like the functions of two variables, or draw like a level curve. That's a reasonable thing, or to draw a trace. I'm not saying he's going to, I'm just saying those things seem like not impossible to do, or find the domain of a function of two variables. So you could be asked for, like, let's go to another page here. So we could be asked for like the domain / range of a function of two variables. Potentially, I would say less likely, but maybe level curves or traces. I don't know. When I've taught classes, I've always tried to, as much as possible, avoid having students graph stuff, because it's usually a pain to grade. That doesn't mean he won't. I'm just saying that was my default. But then the things I think will for sure show up, which is also in this 3D stuff, is the partial derivatives and using them to find and classify relative extrema, or critical points, I should say. That for sure. Like, I can't imagine this not showing up. For sure, this. All right. Sure. Right. Yeah, I mean, it's all about perspective. And then the other stuff in chapter in this, so then there's also Lagrange multipliers. I mean, I should really say this is more like chapter 7. But Lagrange multipliers, I think it was 3, or maybe or functions of more than one variable is another way I would kind of think of this. Or I could use the better word and say multivariable functions, which is a requirement for applying to med school. Whatever. You have to have taken multivariable calculus at some point, I believe, is something most schools require. Lagrange multipliers. And then double integrals. And then all the stuff we've been doing lately, the chapter 10 stuff. So sequences, maybe like finding the pattern for a sequence, although I don't really think you'd ask you that. Usually we focus more on series once we get there. Series. So all of the series stuff, right? Testing for convergence or divergence. Convergence, divergence, etc. So just to write all the things down, we have the nth term test. We have geometric series. We did talk about comparison test, right? Yep. Comparison. Ratio, my favorite. We didn't talk about the root test, right? Right. We talked about the p-series though. And those, I think, are all the tests we really have talked about. So if you're trying to determine the convergence or divergence of a series, one of these tests is where we should be going to. And then finally, the last few things, Taylor polynomials in general, or power series / Taylor. All of it, right? I know, yeah. And then we talked about like differentiating the anti-different. There definitely were some homework questions where you are taking the derivative and antiderivative of a power series. So if you did those homework questions, you might have noticed the thing that we talked about in class a couple classes ago, where I mentioned how if you take the derivative of a power series or the antiderivative of a power series, the radius of convergence stays the same. That's true. So you might get asked to use this to find the radius of convergence of something. Possible. And then finally, the very end, I guess this is the remainder part. Remainder estimate for power series. And finally, Newton's method. Those are all the things I could imagine having to study for this final exam. I posted a couple practice files. I have one other kind of review thing I will probably post as well. So before we get into any specific examples, is there anything I can just generally speak to for anyone? Like, is there anything you would like me to say about any of these topics? Not doing a specific example, just kind of like saying, like, is there something you are unsure about what I'm saying when I say it? Or any of this differential equation stuff? or for any of this other stuff over here. Sorry, I'm zoomed in. Let me zoom back out.
I guess they'll start out like the 3D stuff, like level curves and.
Sure. Sure. So domain is just what we're allowed to have. So typically you're looking for not dividing by 0, so we can't have something over 0. We can't have a square root of a negative. We can't have the logarithm of a negative or 0.
This is not allowed.
Not allowed, right? That's why I said no. What we're allowed. Well, so it's easier to talk about what we're allowed than talk about what we're not allowed to do. So none of the following. So for example, if your function was, say, the square root of 9 minus x squared minus y squared, then our domain would be 9 minus x squared minus y squared has to be greater than or equal to 0. Or x squared plus y squared is less than or equal to 9. Which is the insides of the circle of radius 3, center of the origin. So we're talking about domain, we're talking about some region in the xy plane where this function is defined. So sometimes we might even ask to draw it. And here's the domain of that function. Everything inside and including the circle of the origin of radius 3. Range is kind of more of a pain in the butt. I really would be surprised if you got asked about range, but as far as range goes, you're trying to find the range of this function, you're just trying to find the smallest output and the largest output. The smallest output is going to be, well, the smallest you can get when you take a square root is 0. We can certainly get 0, right? If x equals 3 and y equals 0, then f of 3 comma 0 is the square root of 9 minus 0, which is 0. On the other hand, the largest output is when you're subtracting the smallest thing possible. The smallest x squared and y squared can be is 0. So the smallest is going to be when x is 0, y is 0, and f of 0 comma 0 is the square root of 9 minus 0, which is 3. And there's no other pair or combination of x and y that would give me a bigger value than 3. So here the range for this not too terrible example would be everything as low as 0 to as high as 3. Inclusive. Yeah, just.
Why do you think 0, 0 again?
Because that is the point that makes x and y as small. So when I'm looking at this, I'm really kind of thinking of it more as the square root of 9 minus x squared plus y squared. And then if I'm trying to make a function as large as possible, I'm trying to make the thing I'm subtracting from it as small as possible. So let me ask everybody, what's the smallest that x squared plus y squared can ever equal? Could it ever be negative? No. So if something can never be negative, what's then the next thing that might be the next smallest thing it could be? 0. Can it be 0? Yeah, if x is 0 and y is 0. And that's the only way it can be 0.
When you're looking for a range, you're trying to see what the smallest thing could be.
I'm trying to see the smallest of the output. So I was making this small to make the output as large as possible because I'm subtracting it. Right? When you're subtracting something, if I want to try to make the result big, I want the thing I'm subtracting away from it to be as small as possible. Right? If this were 1, well, 9 minus 1 is going to be smaller. If this is 0, 9 minus 0 is bigger than 9 minus 1. So that's why I'm picking that. And then on the flip side, I was trying to make this as small as possible by making this as big as possible, but I'm limited, right? I can't make this any bigger than 9. Otherwise, 9 minus 9 will be a negative number, and I can't take the square root of a negative number. As far as level curves and traces, let me give you, actually, let's look at this example as well, because I do think it's a worthy example. So as far as level curves go and traces. So for this function, f of xy equal to the square root of 9 minus x squared minus y squared. Or as I would probably like to think of it when I'm trying to think about graphing it, z equal to the square root of 9 minus x squared minus y squared. I'm going to find the traces by setting each of the different variables equal to 0. So for the xy trace, or the trace in the xy plane, I'm going to set z equal to 0. Because to be in the xy plane, z has to be 0. So I'm going to get 0 equal to the square root of 9 minus x squared minus y squared. I'm going to square both sides. I'm going to bring the x squared and y squared over to the left. You get x squared plus y squared equal to 9. So in the xy plane, my trace is a circle of radius 3. In the yz plane, I'm going to set x equal to 0. When I do that, I get z equal to the square root of 9 minus y squared. Now, often when we do this, we just realize, great, I know what the graph looks like. Here, it's a little not as clear. So let's actually do the same kind of thing. Let's square both sides and then add y squared to the left-hand side. Okay, so the answer, this is kind of a tricky question I'm about to ask, but I'll ask it anyway. What kind of graph does y squared plus z squared equal to 9 have? Well, let me ask you all, what kind of graph did x squared plus y squared? It's kind of a circle. Top half though. It is still a circle, but why is it the top half? Well, because z is equal to the square root of 9 minus y squared. And that means z has to be non-negative, right? You can't get a negative value out when you take the square root. So here, the trace in the yz plane is just the top half of the circle of radius 3, or the semicircle of radius 3. Center of the origin. Something that often happens here is that the yz trace and the xz trace often look exactly the same. And they are in this case. We set y equal to 0, we're left with z equal to the square root of 9 minus x squared, which results in exactly the same sort of equation. We're going to get x squared plus z squared equal to 9, which is exactly also a semicircle in the xz plane. Let's draw right there. And then we can also talk about level curves. I think I can put this at the bottom here. So level curves are when you pick other z values for the function to equal. Now, we have to pick z values that are in the range. I couldn't pick z equal to 4 here. If you set 4 equal to this function, you're not going to get any solutions, because the biggest this function can be is 3. So if I set, like, say, z equal to 1, I'm going to get 1 equal to the square root of 9 minus x squared minus y squared. And solving for x squared plus y squared, I get 1 squared equal to 9 minus x squared minus y squared, or x squared plus y squared equal to 9 minus 1. So at a height of 1, right, if I go up a little bit, the level curve is a circle with a smaller radius than 3. So in fact, I'm just going to throw my level curves on here. So this level curve here, this one here in the xy plane is when z is equal to 0. And then when z is equal to 1, I'm going to get a circle of radius square root of 8, which is pretty close to 3. It's like 2.8. The only reason I know that is because the square root of 2 is 1.4, and 2 times that is the square root of 8. So I may be right about there. Label it with z equals 1. And if I plug in z equals 2, now here's what I should do to be smart. I don't want to keep plugging in different values of z to find new level curves, which are all going to be circles. And so what I'm going to do is I say, well, let's say that z is equal to c. And then if I plug in c, I get the square root of c equal to the square root of 9 minus x squared minus y squared. Square both sides. And then solve for x squared plus y squared. And you get 9 minus c squared. So this is a circle, and the radius is the square root of 9 minus c squared. So when c was 0, the radius was the square root of 9 minus 0, which is 3. When c was 1, the radius was the square root of 9 minus 1, which is the square root of 8. And when c is equal to 2, the radius is going to be the square root of 9 minus 2 squared, which is the square root of 5, which is a little bigger than 2. Here's my level curve when z is equal to 2. And not very excitingly, when z is equal to 3, you get the square root of 0 as your radius. So you just get the 1 point right there. So this is really supposed to look like kind of like a top-down map of this function, right? At the very outermost circle, the graph is the lowest, and then you move in, and it goes like you move up, and the radius gets smaller. You move up, the radius gets smaller. You move up, the radius becomes 0. This really does look like the top half of a sphere, and it is. So putting all these things together, you could maybe graph it. Say, well, the bottom is going to be this circle. And then I've got these traces that look like this and like this. And then you can also draw these level curves if you really, really want to. That's kind of the idea of what these level curves are used for, and the traces that are used to help us kind of smash it all together and make the three-dimensional graph at the end of the day. I don't know if he would ask you to do any of this, or maybe just define level curves or just define traces, but it is something that potentially could come up. So, yeah,
The traces part.
sure.
Could we- was it-
Okay. So, yeah. Is there anything in, so okay, I think that's probably the only thing, the only real conceptual thing that we probably need to talk about. Are there any specific things that you would like me to do examples of?
Well, level curve is just setting it to z, right? Or do we-
Well, you're setting z equal to different actual values. But what we often do is we say, I'm going to be lazy and I'm going to say z equals c, and then kind of solve for this in a way that makes it look like something I'm familiar with. So no matter what c value I pick, I see that I have the equation x squared plus y squared equals 9 minus c squared, which is a circle, right? X squared plus y squared equal to a number, and the circle is centered at the origin, and the radius is whatever the square root of that number over there is. So for example, I could draw the level curve when z equals 1/2. I'd set c equal to 1/2. The right hand side would be 9 minus 1/2 squared, which is 9 minus 1/4, which is 8.75. And then the radius of that circle would be the square root of 8.75. But the point is that we don't want to keep doing the same work over and over again. That's why we kind of do this. Like you could go plug in z equals 1, and z equals 2, and z equals 3, and z equals 1/2, and you could just keep going and going and going and never end. So this kind of circumvents that. Other questions? Okay. I think we should look at differential equations, but if you have other things you want to see, we can talk about that. Okay, let's look at some differential equations. Let me grab some. Yeah, let's do this one. Let's solve following. Solve. I have to imagine if he asks you a differential equation, it's probably going to be just solve a differential equation. It's either going to be first order or separable. It could be both. Sorry. So our differential equation is x times y prime minus 2y equal to x to the 4th times natural log of x. And here's what I point out. How do I say this the right way? You definitely know it's not going to be first order if you have powers of y that are other than 1. Or at least once you've gotten it to be just y prime by itself. Like if I divide everything by x, I'll only have a y to the first, right? I won't have any y squareds or y cubes or squared y. So if you have anything funky with y, like a sine of y or y to the third, we know it's not a first order because first order literally means y to the first power. That's what that means when we talk about first order linear. No, that's sorry. That's what the linear part means. The linear part means y is to the first power. The first order part means it's the first derivative of y. So, yeah. First order linear literally means first order y prime, the first derivative, is our only derivative. And linear means y to the first and no other powers or functions of y. I know it's kind of like the similar, so I should write this as dy dx. That's why it's called first order linear, because literally it's first order linear. So if I see something like this, I see that it's almost written in the usual first order linear format. So I'm going to try and make it first order linear because I feel like I'm being given a hint here. So to make it first order linear in the right format, what do I have to do to everything? Right. And so what do I do to everything to isolate y prime? Divide by x. So divide everything by x. So divide by x, divide by x, divide by x. And then I'm going to rewrite this as y prime. And I would write this as plus -2 over x times y equal to x cubed times natural log of x.
Do you recommend just like turning it plus?
I do. Because also that shows the person grading your work that you know what you're doing. You know that you're supposed to write it as y prime plus sum p of x times y equal to sum q of x. And I would even write those things there. There's nothing wrong with writing that. Okay, so now I have to find the integrating factor. Is there how to find the integrating factor? Right, exactly. So our integrating factor is e to the integral of -2 over x. And you can see why that negative sign is so important now. If it was positive 2 over x, you get a different answer than -2 over x. Let me show you what I mean. Integral of -2 over x, let's think of that as e to the -2 times the integral of 1 over x. I know it's been a while. What's the integral of 1 over x? Yeah. Now, the thing here is you should not leave this like this. You should always, always, always simplify your integrating factor as much as you are capable of simplifying it. And this for sure simplifies. The -2 comes up as the power of x. So we can actually write this as e to the natural log of x to the -2, which is just x to the -2. And that is an important distinction to make. Yeah.
Would you put it in the parentheses or?
Yes, in the parentheses. So the thing is, when you're using the power rule for logarithms, you're really saying I have the natural log of x to some power equals that power times the natural log of x. If you write it like this, it's still assumed to be this here. The only thing you can't do is you cannot write it like this. That is not the same. This is not equal to p times natural log of x. Because what this means here, this means the natural log of x times x times x p times, right? Whereas this here means the natural log of x times the natural log of x times the natural log of x p times. Totally different animals. That's the difference there. And it's definitely a big difference. Okay, so back over here. Now in this class, we can just jump straight to the end, right? So we can say, okay, well, great. My function y as a function of x is equal to, I would probably write out the formula if I were a student, just so that in case I make a mistake later, at least they can be like, well, he knew what he was doing. He just made an error. It's 1 over mu times the integral of q times mu. So let's see, that's going to be 1 over x to the -2 times the integral of x cubed times natural log of x times x to the -2. And it is definitely your job to make sure you simplify everything as much as possible before you integrate. So first of all, 1 over x to the -2 seems like a dumb way to write it. Let's write it as just x squared. And in this integral, the x cubed times x to the -2, we should definitely simplify as just x to the first. Right? Those multiply together and give me x to the first times natural log of x. Now here is kind of the bummer for this particular problem. This does require integration by parts. There's no other way around it. Yep, integration by parts is definitely on the table. Why wouldn't it be? Yeah, I guess so. Although that feels like it's less likely to come up in a problem like this. Not that it can come up for anything, but no, I mean, I think the only kind of the integration methods you should still kind of be thinking of in your head. You should definitely know U substitution, and you can certainly come up in a double integral. You should probably know integration by parts. It's somewhat likely to come up in a differential equation like this. But those are really the like. I don't think you really need to focus on partial fractions. I don't think that really comes up in this class. Yeah. So then we would integrate. So let's see. What's our u and what's our dv here? Is what? Correct, right? U is always natural log of x if there's a natural log of x. Right? Remember the acronym LATE. LATE starts with L for logarithm. And then our dv is the rest, which is x dx. Our du is 1 over x dx. And our v is x squared over 2. This is going to end up becoming x squared times all of uv, the natural log of x times x squared over 2, minus the integral of v du, x squared over 2 times 1 over x dx. 1 over x, yeah, dx. Okay. It is always in our interest to simplify the integral before integrating. X squared over 2 times 1 over x is just x over 2.
What's the formula for like the IDV like?
It's u times v minus the integral of v times du. Ultraviolet supervision. So then I would point out that x squared over 2 minus 1 times 1 over x is just x over 2. And the integral of that is going to be, well, the integral of x over 2 is x squared over 4. Plus c, the plus c is vital. And it's vital that that plus c is getting multiplied by the 1 over your integrating factor out here. I would probably choose to leave my answer like this because I'm not trying to invite the opportunity to make more mistakes. So I'd probably leave it like that. But if you wanted to multiply the x squared through, you could say it's going to be natural log of x times x to the 4th over 2 minus x to the 4th over 4 plus c times x squared. That's also a valid way of writing this answer here. But the c does have to multiply that x squared. For an added bonus, someone could say, okay, great, you solved it. Now, given the initial condition that y is equal to 5 when x is equal to 1, find c. Or really, I should say, the better question is, find the particular solution. So let's see, I've got my function. I've got that y as a function of x is equal to x squared times the natural log of x times x squared over 2 minus x squared over 4, c. And now we're just going to plug in. Y is 5, so I'm going to plug in a 5 over here, and x is 1. Take it 1 times the quantity, natural log of 1 times 1/2 minus 1/4 plus c. What's natural log of 1? Yeah. So really, all we have is that 5 is equal to negative 1/4 plus c. Or if you add 1/4, c is equal to 5 plus 1/4. If it were me at this stage, I would probably just go over to decimals. I don't want to you shouldn't leave your answer as 5 plus 1/4 because you just shouldn't. I don't want to get I don't want to get like a mixed fraction here just because I don't want to work that hard. I can very quickly say that's 5.25. Right, we all know that 1/4 is 25 cents. So 1/4 is 0.25 of 1.
Or leave it as like, we just leave like It's actually 1/4.
You could also do that. I'm just saying, it feels to me like it's easier for this particular number to do 5.25. But you're totally welcome to write as 21/4. And now, if I just said find C, that'd be the end of it. But since I said find the particular solution, we then have to go back and throw that C value into our general solution. Say our particular solution is y of x equal to x squared times natural log of x times x squared over 2 minus x squared over 4 plus 21/4 or 5.25 if you like. Cool.
What's the order for the weight again? Like logarithm.
So the late acronym is when you're using integration by parts, how we decide what to set u equal to. So if there's a logarithm, you set u equal to a logarithm. In fact, let me just write it down over here. So integration by parts, you're trying to find the integral of u dv equal to u times v minus the integral of v du. And our job is to identify the u and the dv. Really, the usual process is find u and then the rest is dv. Find u and whatever's left is dv. So first, if you have a logarithm, usually natural log, although technically any log can be chosen, but hopefully you're not integrating log base 3 because that's just kind of awful. And then after logarithms, you have what some people call algebraic terms, or I say any power of your variable. And then trig. And then finally, an e to the x. Or exponential. You will almost never let u equal an e to the x when you're doing integration by parts. Totally fine if you're doing u substitution, but not, this is only for integration by parts. If you see a logarithm and you're trying integration by parts, let u equal the logarithm and dv is everything else. Like in this problem, right? U is equal to, or in this problem here, right? U is equal to our logarithm and dv was equal to everything else, x times dx. Okay. Wow, it's almost, time flies. 150. What else should we look at? Is there anything else you specifically would like to look at? Range, function of two variables, critical points. Sure, relative extrema. Let's do a relative extrema problem. I would be very, very surprised if there wasn't a relative extrema question on your exam. It feels like it's a pretty standard thing to ask about. There's not one on here.
Oh, that was the first question.
Sure. Let me just go grab one. Let me grab one of these examples here. Sorry, I just want to make sure I pick this problem that's not too terrible here. Where's all my examples? From which exam? Sure, let me just pull it up. Practice midterm from his exam? Oh, sure, let's see. 1 second. Co-16C, 16C. Where does he have his exams posted? Oh, on grade. I can't access. Does he not have them just posted on?
It was f is
Sure.
f is equal to negative 2x cubed plus 6xy minus y squared plus 3.
Cool. So there's always a process for finding and classifying the relative extrema of a function of two variables. The first step, find your partial derivatives, set them both equal to 0. So my x partial derivative is going to be negative 6x squared plus 6y. That's it? Yeah, that's it. My fy is going to be 0 plus 6x minus 2y. So both of these look actually not too terrible. You could kind of pick either one to solve for. You should do it. So here's what I'd say. No, let's do it. So I would probably pick the one that looks slightly easier, which is this one. So I'm going to say, great, 6x equals 2y. Do I want to divide by, do I want to end up getting y equals something with x or x equals something with y? Right. And the only reason that's the choice I would make here is because it looks nicer, right? We could divide both sides by 6 and get x equals 2y over 6, which is x equal to y over 3. What I'd rather do, divide everything by 2 and get 6x divided by 2 equals y, and then 3x equals y. So if you have a choice where it feels pretty much the same either way, try to make the choice where you have nicer numbers. I'd rather deal with 3x than 1/3 y. So then we take that and we substitute it into the other equation. I'm going to take that equation and I'm going to say, okay, great. Now I have negative 6x squared plus 6 times 3x equal to 0. And now I'm going to try and simplify this. So I have negative 6x squared plus 18x equals 0. I should factor. So important point here. Let me show you the wrong way to do this. Just don't write this down, but let me just show you the wrong way to solve this. If I solve this the wrong way, I can say, okay, 18x equals 6x squared. And then what can I divide both sides by? Yeah, 6x, 3x, either one. If I divide both sides by 6x, I'm going to get 3 on the left and x on the right. And that's not wrong, but that's not all the critical values. You're missing an obvious one, x equals 0. So the thing is, we don't want to solve it that way. We want to solve it by factoring. Factor out a 6x. You're left with a negative x plus 3. Or if you prefer, factor out a negative 6x, and you're left with a positive x minus 3. So that my critical values are, well, my x parts of my critical values are either x equals 0 or x equals 3. And then go back over here and say, oh, but y equals 3x. So if x equals 0, we're going to get y equal to 3 times 0. And if x equals 3, we're going to get y equal to 3 times 3, which is 9. So my two critical points are 0, 0, and 3, 9. Now what do we have to do? Plug it back into what? That would be potentially true if you were doing something like finding absolute maximum minimum, but that's not what we're asking here. We're finding relative extrema. What thing do we need to calculate so that we can then plug these things into that thing to tell us? What's it called? But what's the letter we use for it? You're right. Yeah, it's the FXX thing. It's typically called capital D for determinant of a matrix that we don't talk about. And it's equal to fxx times fyy minus fxy times fyx. But we usually just simplify it as fxy squared. You definitely need to memorize that. Yeah. So then, in this particular case, oh, let's see here. Our fx was negative 6x squared plus 6y. So our fxx is going to be negative 12x. Our fyy is going to be negative 2. And our fxy is going to end up being, let's see, fx with respect to y is going to be 6. Or fy with respect to x is also going to be 6. So it should be 6 squared. Generally, I would not simplify this. I would just plug in. So if I plug in 0, 0, I end up getting 0 times negative 2 minus 36. I don't care what this is equal to. I just care whether it's, right, so this one is a positive or negative? Negative. And if your D is negative, that means our point is right. Let's look at the other one. D of 3, 9, I believe. Yeah. So we plug that in, I'm going to get negative 12 times 3 times negative 2 minus 6 squared. Okay, here's where I probably actually should calculate it. So just looking at it, I need to do a little bit more thinking. let's see, that's 36 times 2 minus 36. Oh, well, that's definitely positive. Now when it's positive, it could be either a max or a min. So now what do we look at? Well, I want to use a different word. But you're not wrong, but we're going to look at the concavity. Because if the function is concave up, then what do we have? If it's concave down, what do we have? So how do we tell if it's concave up or down? You have to plug it back in. You just have to look at the second derivative, either fxx or fyy. Well, here's fxx. Here's fyy. Are they going to be positive or negative? They have to be negative, right? There's no choice. Because fyy is always negative. But also, if you plug in 3 for x, fxx is also. But if you see that one of them is already always either positive or negative, you're done. You know this one's going to be concave down. So if I wrote this, I would then say fyy is negative, which means we are concave down. And I would actually write these words, maybe just CD, so that the person again knows that you know what you're doing. And then, oh, concave down means we have a relative maximum. So if D is positive, then if fxx or fyy, because they'll be the same, if either one of those is greater than 0, then we are concave up, which means we have a relative minimum. And the opposite for the other way. If either one of them is negative, then we are concave down, which means we have a relative maximum. And then if D is negative, we have a saddle. And if D is equal to 0, we are sad because we don't. Inconclusive. Kind of like when the ratio test is equal to 1. Inconclusive. It's probably not going to happen, right? If it's happening on a test, someone is asking you kind of a very challenging question, and they're saying, well, here's the thing where D is equal to 0. Justify to me anyway why it's a relative minimum or a relative maximum. I will point out, just because it's not too hard to see, if your function was x to the 4th plus y to the 4th, I will just tell you really quickly here that your only critical point is 0, 0. And if you plug that into fxx, fyy minus fxy squared, well, fxx is 12x cubed, fyy is 12y cubed, and fxy is 0. So you get 12x squared times 12y squared minus 0. And if you plug in 0, 0, what do you get? You get 0. How could you convince me that 0, 0 is still a relative minimum, even though this test is inconclusive? Well, if you plug in 0, 0, what is, oh, sorry, f of x, y. What is f of 0, 0? Okay. If you plug in any other point, is the value going to be bigger than 0? Yeah, because x to the 4th is always positive, and y to the 4th is always positive. Yeah, them together is always positive. So f of x comma y is always greater than 0 for any other coordinates. Very unlikely, but you guys asked, so I wouldn't ask this question. Not a good test question. All right, it is 2:01. Stop talking. I'm gonna head over to pads.